In this video, we're going to use a tangent plane in order to approximate a point or a value of a function rather than having to plug in that value into the function. So, for the first problem, our function will be e to the power of x times sine to the power of y is equal to f of xy. And you want to approximate from the point 0, 1 and approximate the value of the point at 0.2, 1.1. So what does this mean? Well, we're going to find the tangent plane at 0, 1, and then we're just going to plug in the values of q into the equation of the tangent plane in order to get our approximation. And typically, this method is used whenever you're, an engineer and you have some function that is somewhat complicated to plug in every single value for hundreds of times, so you just use linear approximation. Hopefully you get close. So first thing you have to do, in order to find the equation of the tangent plane, you have to find the gradient value. So the gradient consists of the x partial and the y partial. So the x partial here is just e to the power of x sine to the power of y. The x partial is e to the power of x cosine to the power times y, cosine of y. And once we have these values, we can plug in the values for point. So currently, our gradient is e to the power of x sine to the power of y, e to the power of x cosine to the power of y. And if we plug in the values 0 and 1 into our point, we get e to the power of 0. So e to the power of 0, sine to the power of 1, sine of 1, and e to the power of 0, cosine of 1. Let's simplify this gradient. So once this is simplified, our gradient is simply just sine of 1 and cosine of 1. And you don't have to turn this into some number. You can just leave it sine of 1. That is a constant. So once you have that, we're going to plug in the gradients into our equation. So z minus z null, and this is our standard form for our, or standard equation for our tangent plane. So this is f of x times x minus x null plus f of y times y minus y null. So our z null value isn't found yet, so let's just go ahead and find that right now. So in order to find a z null value, we just have to plug in 0 and 1 into our function, and plugging in 0 and 1, we get sine of 1. So this is our z null value. So if we subtract sine of 1 from z, and we plug in for our f of x, our f of x is sine of 1 here, times x minus x null, which is just 0, so it's just sine of 1 times x. Actually, just put the x in parentheses. Plus f of y, which is just cosine of 1. Times y minus y null, which is just 1. So this is our equation for our tangent plane. But once we have this equation, all we have to do is plug in the values of q into the tangent plane, and we get a planar approximation. So we have z minus, so technically this is just z is equal to sine of 1 times 0.2 plus, notice how the 0.2 is the x value of our q, and we plugged in 0.2 for the x value inside of this function, times cosine of 1 times y minus, actually 1.1 minus 1 plus sine of 1, because we moved the sine of 1 into the other side. So our z values isolate here. And once you get some constant, most of the time in higher level math, most people don't really care if you simplify it or not. So this value would be correct. Next question will be x to the power of 2 times y plus x times y to the power of 2 is equal to f of xy. And we're going to find the tangent plane at point 3, 3. We're going to approximate 3.01 and 2.99. We're going to approximate at this point, and we're going to use this point to approximate this with. So at this point, we're finding the tangent plane at P. For that, we got to find the gradient now. So f of x and f of y. So f of x's gradient will be 2xy plus y squared. And f of y's gradient is x squared. No, y partial, sorry. I don't know why I'm mixing up my words. X squared, and this is just 2xy as well. So we plug in our values for P, so f of y, 3, 3. So we plug in our values, we get 3 times 3 times 2, which is 18, plus 3 to the power of 2, which is 9. And this is 9 plus 18. And we get 27 here. So we have our gradient. So our gradient is f 27, 27. And once we have our gradient, we can plug in the values of, let's first find z null actually. F of 3, 3 is 9 times 3 plus 3 times 9, which is equal to 27, plus 27, which is 54, which is our z null value. So we have z minus 54 is equal to 27, our x partial, times x minus x null, which is 3, plus 27, our y partial, times y minus 3. And in order to approximate, again, we just have to plug in for the values of q. And for this, let's go ahead and isolate z first. And when you isolate z, all you do is get plus 54 here. So if we plug in our values of q to get our approximation, we get 3.01 minus 3 plus 27 times 2.99 minus 3 plus 54, which is our final answer. And this is a constant, so technically your answer is right. The last problem, we'll be using the function ln of x plus y is equal to f of x comma y. We're going to approximate the function at point. We're gonna get the tangent plane at 0.11, and we're going to approximate at 1.05 and 0.95. And then once we get this, we have to find the gradient. So we have to find the x partials and the y partials. So the x partial of this is just 1 over x plus y, and the y partial is still the same, 1 over x plus y. If we plug in our values for the points, we get f of 1 comma 1, fy 1 comma 1, and we get 1/2 for both. And now our gradient is 1/2, 1/2. Once we have 1/2, 1/2, let's do find the equation of the line, but first we need to find our z null value. So just plug in our values into the function, our point into the function, and we get ln of 1 plus 1, which is equals to ln of 2, which is equal to our z null value. So this is z. And let's move on. Let's move to ln to the other side of the equation first to isolate z, so we don't have to do that later. We get 1/2, which is our f gradient, x value for our gradient, x minus 1 plus 1/2 y minus 1 plus our z null value, which was ln of 2. Then once we get this, all we have to do is plug in the values for q. So z is equal to 1/2 1.05 minus 1 plus 1/2 0.95 minus 1 plus ln of 2. So to recap, all we did was find the equation of our tangent plane, which is this. So our equation of tangent plane is this, at some point near what we are approximating. So you can find the equation of tangent plane using, typically you would want to use integers for the equation of this tangent plane, because 1 and 1 are easier to solve for than 1.05 when you're plugging stuff in. And once we find our equation of our tangent plane here, we just plugged in the value of wherever we're trying to approximate at, which in this case is 1.05 for the x value. So we plugged it in for the x value and 0.95 for the y value. So if you have any questions, put it down in the comment section.